Welcome to my CPE 301 Midterm 2 Task 4 video. In this video, I'll be using the PID algorithm to set a DC motor at a set speed and maintain that speed. So going into the code a little bit here, we're using a 16 megahertz clock. The three values here for the PID, I kind of messed around with these a little bit to optimize the output so we get more of a straight line output and less of those spikes in there. You'll see that in a second here when we open up the visualizer. We got a lot of variables here. Our initialized functions, ADC. We have a transmit to the terminal function. Here we can see we're using our timer 2 as our compare timer, and then timer 1's running our DC motor, PWM, and also our capture. So we're using PB1 as our output, the OC2A. Port B is our input that we're reading from the motor for our ticks. We're just initializing an array here. So if you go into our timer 2 compare, this is what we're doing. We're calculating the error and calculating our PID. We have this check in here that if the PID is greater than our duty cycle max, we're setting it to the max, and if it's not, then we're keeping it at 0. OCR1, this is like a correction factor here to scale it from our duty cycle. Going into our timer 1 capture vector, ISR, we have kind of like four stages here. So once you enter this first one here, we're recording our ICR1 value to our tick, and then we're incrementing a count, which is the count because determines which position we're in here, and then we're toggling the capture pin on our timer 1 timer. So what's happening is when we first go in, we're looking for the rising edge, and then we're toggling it, so the next time we go in, we're looking for the falling edge, toggling, rising, so on and so forth. Then it's our finish, or our fourth step here, or actually would be our fifth step here. This is where we're calculating the difference between our capture 3 and capture 1, capture 4 and capture 2, and then adding them up to get our total ticks. We're resetting our timer 1, and then this overflow vector here, if that hit, that was just to count how many overflows we hit. And the finish 0 sets this all back to 0 to go back into it and restart again. So I'm going to go ahead, and also to note real quick here, this is right here where our set speed is set to 60 in this code. And that's what we're shooting for. So I'm going to go ahead and start this up. And you can see that as I provide a little bit of resistance, you can hear the motor kind of bog down a little bit, but then it speeds right back up. So if we go ahead and open this up, you can see from our terminal window here, we're starting to stay right at 60. And it kind of bogs down, and then it picks right back up to 60. So printing to the terminal shows that our code is working. And then if we go ahead and bring up the data visualizer here, make sure you can see it. Actually, that's small. So you can see right here we're holding right at 60. We apply a little resistance to it, and it slows down, but it moves right back up to 60 where we want to keep it at. So the PID is working. It's maintaining speed as expected, and the code worked as it functioned. Thank you for watching my video.